Hey guys, howdy. Let's get started with testing releases and cutovers. So the rolling update feature can work well for a simple blue-green deployment scenario. However, in the real world, blue-green deployment with a stack of multiple applications, there can be a variety of interdependencies that require in-depth testing. The update period command allows us to add a timeout flag where some testing can be done, but this will not always be satisfactory for testing purposes. Similarly, you may want partial changes to persist for a longer time and all the way up to the load balancer or service level. So, for example, you may wish to run an A B test on a new user interface feature with a portion of your users. Another example is running a canary release, a replica in this case of your application on new infrastructure like newly added cluster node. Let's take a look at the A/B testing example which we have shared here. For this example, we will need to create a new service that uses session affinity. We will set the affinity to client IP, which will allow us to forward client to the same backend part. This is a key if we want a portion of our users to see one version while another see another. Now you can see the program or the code here on the screen. Now create this service as usual with the create command as follows, which you can see here. This will create a service that will point to our pods running both versions 0.2 and 0.3 of the application. Next, we will create the two RCs that create two replicas of the application. One set will have a version 0.2 of the application and the other will have a version 0.3 as shown here below. You can see this. Okay, and this particular code is pod A controller YAML, and the second one is again pod B controller YAML. So note that we have the same service level so that the replica will also be added to the service pool based on this selector. We also have the liveness probe and readiness probe defined to make sure that our new version is working as expected. Again, use the create command to spin up the controller, as you can see here. Now we have a service balancing to both version of our app. In true A/B testing, we would now want to start collecting metrics on the visit to each version. Again, we have session affinities set up to client IP, so all requests will go to the same parts. Some users will see version 0.2 and some will see version 0.3. Now, just a footnote is because we have session affinity turned on, your test will likely show the same version every time. This is expected and you would need to attempt a connection from multiple IP addresses to see both users experiencing with each version. Now, since the versions are each on their own part, one can easily separate loggings and even add a logging container to the pod definition for a sidecar logging pattern. Now, for brevity, we will not cover this setup in the book but our lecture, but we will look at some of the logging tools of course, and you will see those in the subsequent lectures which I would be covering. We can start to see how this process and will be useful for canary release or a manual blue-green deployment. We can also see how easy to launch a new version and slowly transition over the new release. Now let's take a look at the basic transition quickly. It's really as simple as a few scale commands which you can see here. Just a footnote again, use the get pods command combined with -1 filter in between the scale command to watch the transition as it happens. Now we have fully transitioned over version 0.3, which is node-js-scale-b. and all users will now see the version 0.3 of the site. We have 4 replicas of version 0.3 and none of 0.2. If you run a get rc command, you will notice that we still have an rc for 0.2. So as a final cleanup, we can remove that controller completely, using this command. And this we have discussed in depth earlier as well. Let me quickly move to the next subtitle, which is application auto scaling. A recent feature addition to Kubernetes is that of the horizontal pod autoscaler. This resource type is really useful as it gives us a way to automatically set thresholds for scaling our applications. Currently, that support is only for CPU, but there is an alpha support for custom application metrics as well. Now let's use the node-js scale replication controller from the beginning of the lesson and add an auto scaling component. Now before we start, let's make sure we are scaled back down to one replica using the command as mentioned here, which is kubectl scale replica 1 and jscale, which you can see here at the top. Now we can create a horizontal pod autoscaler with the following HPA definition, which you can see here. Yes. So this is a node-js-scale.hpa YML program, and we need to go ahead and create this with kubectl1 create-f command as well. Now we can list the HPAs and get a description as well, and the command would be as mentioned here. So we can also create auto scaling in the command line with kubectl1 auto scale command. The preceding YML looks like something like this. So this will show us an autoscaler on the node -js-scale. So replication controller with a target of CPU of 30%. So additionally, you will see the minimum pods is set up to 1 and maximum is 3. This you can see here. Okay, so let's also query our pods to see how many are running right now, and we would be using this command for the same. Let me quickly flip the screen. Yeah, we should see only node-js-scale pod because our HPA is showing 0% utilization. So we will need to generate some load. We will use the popular Boom application common in many container demos. The following listing, as you can see on the screen right now, will help us create continuous load until we can hit the CPU threshold for autoscaler. Now this is the code you can refer to. I mean, it is self-explanatory, so I'm not taking much time explaining the code itself. This is boomload.yml. Now use the kubectl1 create-f command with a listing, and then be ready to start monitoring the HPA. We can do this with kubectl1 get HPA command, which also we have used earlier. It may take a few moments, but we should start to see the current CPU utilization increase once it goes above 20% threshold. We said the autoscaler will kick in, as you can see here. Okay, so once we see this, we can kubectl1 get pod again and see there are now several node-js-scale pods, which you can see here. We can clean up now by killing our load generation pod by using this command. So I think everyone understood this. Now if we watch the HPA, we should start to see the CPU usage drop. It may take a few minutes, but eventually we will go back down to 0% CPU load. Okay, so with that, I'm taking a pause again, to move on to the next lecture. In the next lecture, we would be talking about few other interesting aspects related to it. Till then, thank you very much.